Hello there, we're continuing on with our physics platformer lesson. At the end of the last part of this lesson, we had our little player reacting to gravity, falling down appropriately, and moving left and right. We're having some issues with the jumping, but that's fine, we'll get that fixed. Okay, let's continue on. What I'd like to do next is let's get the appropriate sprites to show up for our player. Okay, let me expand this out a little so we can see what's going on. So we've taken care of our movements now. Now let's take care of showing the right sprite. As with everything else in this physics world, the way that we update the sprites is going to be a little bit different. Okay? One thing we want to know is, for example, if our player is moving, then we want to show our walk sprite, and if our player is not moving, then we want to show the idle sprite. So in the old way of doing things, or the non-physics way of doing things, was to just check their horizontal speed, and if their horizontal speed was 0, then that meant they weren't moving, and we could show the idle sprite. Well, we don't have a horizontal speed, at least not in the same way, but we have a physics-specific version of that called physics speed x. And our physics speed x we're going to set, okay? And what are we doing when I say we're going to set this physics speed x? Well, it's just like setting our horizontal speed when we're not using physics. We can set it to something in order to give it a speed in a given direction, left or right. We want to cap the speed of our player going left or right. And so to do that, we're going to use max. This is a built-in math function. And then confusingly, let me type this in. We're going to say phys speed x max speed. Okay. So what in the heck does that mean? Okay. Well, let me finish this. Minus max x speed. Okay, let me update this to make sure I've got it correct. All right, let me explain what we're doing. Basically, we're going to clamp the player's speed so that he can't go any faster than the max speed that we set back in create, which we set to 3. Okay. So what we're going to do is we are going to check each step to see what is the speed that we are going currently that is represented in the physics world by this phi speed x, or physics speed x, I think of it. And we're going to compare which is smaller, the maximum speed or the current x speed. Whichever of those is smaller, we'll keep, okay? Then we will do a comparison between that value and the negative version of that value and return the larger of the two. So that's what we're doing here. This allows us to cap the maximum speed, and also by doing this outer check here, it's going to make sure that we are storing a value that is the negative or positive correctly. Okay? All right. So we do that first. That's capping our speed. Let me put a little comment here. Cap our horizontal speed. Then let's figure out if we need to show the idle sprite or the moving sprite. So I'm going to say if our speed x is greater than 0.1, that means our player is moving, or our speed x is less than negative 0.1, well, that means that we're moving. Okay? I think there's probably a better way to do this than having to do this or check, but this will work. Then if we're moving, we want to show the sprite index for moving, which is SPR underscore player walk. Else, if we're not moving, then we want to show the idle sprite. Okay, let's take a quick look at that. I still think our jumping's not working, but that's fine. All right. In here, now you can see if he's moving, hey, he's showing the movement sprite. Still not showing the correct direction, but we can set that in a second using image X scale, right? Nifty. And because we're using the physics engine, I hope you'll notice that he is slowly picking up speed and then coming to a halt slowly as well. Sweet, so we're getting closer on there. It'd be nice if we show the correct left or right. So why don't we set that up? So we can say, oh, let's see. How about if phi speed x is not equal to 0, then image X scale, if I can type correctly, equals, I can't type correctly, that's clearly, there we go, equals sine, oh, I hope this looks familiar, speed X. Okay, so as long as our guy is moving, meaning our x speed's not 0, then we're going to set the x scale equal to the sine of the x speed, which is going to be negative or positive. If it's going right, positive. If it's going left, negative. And so that will flip us around as needed. Okay. Let's put a comment in here. Flip image correctly for left and right. So far, so good. Let's make sure that we're showing the correct sprite when the character is flying up in the air or not. So we'll again here we'll do an if, and we'll say if phi speed y is less than negative 0.3, then what do we want to do? We want to show a specific sprite index, and the one that we want to show is jump, which is the one that we're showing when the character is moving upward in the air. That's why we're checking less than a negative value, meaning that it's moving upward. Else, we want to show the sprite that shows the player falling, which is SPR player fall. Let's save all that and see what that looks like. It may still be that our jump doesn't work. Let's see. Okay, here we go. As he's falling, he's showing the right one. Now there's some weird issue. You can see he's kind of stuck. He's stuck in this dropping one. So this is all connected with some weird something that's happening with our little guy and being able to detect whether or not he is on top of this platform or stuck. Here it assumes that he's still falling. So we need to do a little fixing here. Alright, well, we are in debug mode. So let's walk through and check what could be causing the problem with our player getting stuck in the ground. Well, there's things that may or may not be related, but here's something we should fix. If you look at the key jump section here on detecting input, for the W key, we're using keyboard check pressed, but for the virtual key up, we're using keyboard check, so let's fix that. That won't actually make a difference as far as I can tell, but we do want to make sure that we're doing check press, not checked. And the reason why is if we do regular check, the player can give an almighty jump to their character. Let's keep debugging. Coming down, it is reasonable to assume, since we're having trouble with jumping, that something is occurring here inside the jump section. So we checked and fixed this one. That's good. Now let's look down in here, and you'll see that in the check to see if the player has pressed the jump key, we're doing what we're supposed to do, checking one below us and seeing if we're going to run into something. Now look at what we're doing here. We're doing physics apply force, and if I open up help and look at that, what physics apply force is going to do is going to continuously apply a force to this object. And we don't actually want to do that in this case. Now this is a little confusing because on the walk we did say physics apply force. We continue to apply a force. So the object is going to go faster and faster and faster as we hold down the left or right keys. But for the jump, for one thing, we're just doing keyboard check pressed, meaning it's only going to do a quick check when the player presses the key down, and they have to release the key and press the key again in order for it to set this to true again. In a related fashion, we don't want to continuously apply force. Rather, we want to just apply a burst of force, or an impulse, which is its own built-in method that is just going to apply an impulse to this object. Just apply it and then stop applying force to that object. So I'm going to do the same thing here. Here's our regular jump. Here is our secondary jump. This may not fix the image issue where we look like the player is still falling even when he's sitting on the ground, but I'll bet anything this is going to fix our problem with jumping. So we still have an issue with the image. That's fine. We can fix that. But hey, now we can jump up in the air. We can get probably a too powerful secondary jump on there. So we might want to adjust that. You can see if I press just one jump, I get this. And depending on the timing of my second jump, I can get a probably too powerful jump. If I wait. This basically, the smaller the force is, or the less, I should say, that the momentum is moving upward, the less powerful that second jump will be. So we might want to adjust that a little bit so they can't jump quite so hard. So maybe on this second one we'll say jump force times 0.7, just to make that second jump a little bit less powerful. So cool. So we've fixed the main problem with our jumping, mainly that we didn't jump, but we still have to work on the weird issue of our guy not showing the correct one, which is fine. We can fix that. And you can see now my second jump's not quite as powerful. It's still a little, probably too powerful. Yay! Jump up in the air. So we'll play around a little to get that working the way we want as well, and we'll fix the weird issue with the images. So let's continue on. So we have all of those things showing up. Another thing I'd like to do is I'm going to want to have the character sprite animate in relationship to how quickly he's moving through the room. So if the character is moving slowly left or right, I want the frames in the animation to animate slowly, and if he's moving more quickly, I want the frames to animate more quickly. So we can do that here. So we're going to change animation speed depending on actual movement speed. And the way we can do that is to say, let's set the image speed equal to this built-in speed x value, okay, divided by 10. All right. So what does that mean? Well, let's take a look. It's going to take whatever their x speed is in the physics, and it's going to animate it well, we can't see because we're having this issue with the guy not moving correctly. So in order to see that, we got to fix that error. So let's do that next. All right, well, the issue we're having is that when the player falls, we never switch back into the walk or idle. We just stay with the falling. And I found it. I wonder if you can see it. Here we're doing a check. If the y speed is less than negative 0.3, we're showing the jump. And then we've got an else. Well, this else basically is going to override all of this other stuff, because in any instance in which our y speed is greater or equal to negative 0.3, it's going to update the sprite index to say this, which is not what we want to do. So let's get rid of this else, and let's replace it with this. If the y speed is greater than what? Greater than 0.3, meaning that we are falling, then set the sprite index to fall. So essentially between 0.3 and or negative 0.3 and 0.3, that will allow us to show these two. And it's only if we are below that on the y speed or above that on the y speed that we're going to show the jumping or falling sprites. Good grief. So if we come back in here, now he falls, and look at there, he turns back into the guy. And we've set up that code so that when he is moving slowly, he animates slowly. You see this? He's just barely animating. And then as I speed up, he speeds up. Very cool, right? Still, the physics are a little funky. I think he has kind of too powerful a movement. And at this point, it's a matter of playing with how strong the gravity is. It's a matter of playing with, how much force you give on his jumping and so on. But essentially, this is it. You've got the guy set up. Let's do a couple of more cool things here. Right now in our game, if the player's moving along, we have a kind of static background. It would be nice to include a parallax effect for our background. So let's do that really quick down here at the bottom. And in our room, if we go back out into the room, you can see we have a background layer that's simply called background. And we can talk to this layer, and in talking to the layer, we can update its X and Y position, okay? And we can update its X and Y position as follows. We can say layer X. So this is going to update the X coordinate of a layer that's in your room. And which layer do we want to update the X coordinate for? The one that's called background. And what do we want its X coordinate to be? We're going to say minus our X position, using this physics position X, divided by 5. This is going to have the background move essentially in the opposite direction that the player is moving. So if the player is moving to the right, the background's going to move to the left. The player is moving to the left, the background's going to move to the right. We can do the same thing with the layer Y position using the position Y negative divided by 5 as well. This divided by 5 is just my made-up number. You can try something different to see what effect it has on movement. But with that set up, we'll get a cool effect. Now if I jump, then the background moves with me. Isn't that neat? Move left and right, move at an angle. You can see we have the background moving in a way that sort of visually makes sense and matches what you often see in these kinds of games. All right. And he just keeps falling forever, so the background is falling forever. And we need to fix that. So how do we fix that? Well, that's not in this step event. Instead, let's go to our player and add an event called Other and Outside Room. And what we're going to do in Outside Room is we're going to update the player's X and Y position. So we use the physics position X, and we're going to set it to start X. Remember, we set that up in our create event. So this will essentially, it's not actually restarting the room. Instead, it's going to reposition the player back to where the player was initially. Okay. Take a look at how that looks. Let our player drop to his death, and then he just drops right back down into the room again, where he was. Excellent. Is there anything else we want to do on this? Maybe for a final bit of cleanup. In our platformer, we used cameras, and I had you go through and set up a camera. There is an older way that is a leftover from an earlier version of GameMaker that you can still use if you just need a quick and dirty way to have a camera that's focused in on the player. So I'm going to do that. I'm going to go back into my room, and let's take a look at our room settings. Let me drag all this up like so. And down at the bottom, there's our viewports and cameras. This is where we set up our camera before. And you remember we enabled a viewport. The old school way does the same thing. We're going to open up viewport 0, and we're going to make that visible. Then we can decide how big we want that viewport to be. So it's going to be visible, and I'm going to choose this clear viewport background. And for the size of the viewport, let's set it to say 640 by 360. And this is the camera, so you can see it represented out in the room. And then this where it says viewport properties, I'm going to set this to 1280 by 620. That's basically going to be how big the window is when we run this on our computer. Okay? And then something we've not used before is this object following setting. We can just choose something to follow our player. We did all this through code before, but we can do it here as well. Let me show you. We're going to make a few more settings, but I want to show you so far what this looks like. So it's going to automatically follow the player around, the camera, I should say. And you can see in the viewport, we've caused it to have this long, wide window. And as we move along, it follows the player along. And it just moves right as the player reaches the edge of the screen. It starts to move, which is not exactly what I want. So I'm going to play around with this horizontal border and vertical border to fix that. I'm going to set the horizontal border to 480. I'm going to set the vertical border to 300. And you can see what that looks like. That's going to make it so that the camera is going to start moving as soon as the player is within 480 pixels of the left or right of the screen. So you see how that works? Pretty cool, right? So basically we're just saying when the player is anywhere outside of the center of the screen, get the camera to start moving with our player. Okay. Now we're looking like a real platformer. And that is it. Okay, so that's a nice introduction to the use of physics in a platformer. Just to summarize, you need to make each object in the room that you're going to be using in a physics world use physics. You need to make the room itself use physics. And then you need to alter the way that you update the position of things from the old way, which was using X and Y, to using physics-specific versions of those things, basically phi position X and phi position Y. And then you apply force to objects either in an impulse, so it just quickly applies force and then stops, or as force, meaning an ongoing application of force to an object. That's it. I hope you had fun. You can use this to build a platformer as well, and take it away.